Couple words about our company. ProtoRhino is founded by two industrial physicists, and what we are good at is making proof of concepts and pilots for digitalization and IoT cases, and we also make custom instrumentation mainly for universities. Couple words about digitalization and IoT from industrial physicist point of view. So at the moment, what we see a lot is that different kind of networks and IoT platforms, they are really overrepresented in marketing and sales, and this is mainly because there's so huge market potential there. So all big players are competing in there. But if you want to really make a killer solution for this kind of application, it's not about the IoT platform or network which you choose, it's the application itself. About one other thing about big data, the huge amount of data is the results of new measurement possibilities instead of being the goal itself. So when you use term or you hear this term that just gathering a lot of data is the goal, I would say that if you don't know what you will do with the data, that is just lazy approach. But still it's better than not doing anything. Concrete example what we have been doing, because we don't have any public reference from forest industry, our concrete example is about concrete. So if you have seen any newspapers opened, you have seen this problem in Finland that we have a huge problem with concrete quality at the moment. I don't go too much on detail why this is so, but this is good motivation for concrete industry to make some changes. And the proposal, what we should be able to do in concrete life cycle is to actually measure the concrete quality through the whole life cycle, all the way from concrete plant to final structures, and use the data from each phase in one network where we can, or cloud, where we can actually make sure that the quality is right through the whole process. So combining data from each stage, we get more cost-efficient, ecological and safe concrete structures. So many cases when you have, you want to change some industry, it's not best idea to found a startup which there is a 3 people and they try to change how the whole industry is working. So here the approach is that we gathered companies from construction industry and made this kind of planning group where the aim is to first find and define the problem, what are the key points and how the solution should work that we can get something functional working. A couple of points about this kind of planning group is that you should have like people through the, or represented through the whole life cycle, and then you also need to have the players who can actually do the industry digitalization, and then the part which can do actually the research and innovation part. And when gathering this kind of collaboration, it's not quite often in Finland it has this is done by, okay, we need to apply Tekes funding, so let's gather people who wants to get Tekes funding. This time we did it differently, so we basically, I'm the coordinator of this project and I go to companies, okay, do you want to be part of this change or not? Okay, what can we apply from this to forest industry? Okay, this looks quite same, and I guess Tieto presentation had same kind of idea, but forest industry life cycle, so we should be able to get data through the whole process. From the forest management side, harvesting part, on felling, logistic, how to transport it, and then processing side, pulp mill and sawmill. So how to combine data from each stage to get more cost-efficient and ecological forest industry. Now, only question is that in concrete industry, there's really big motivation to change because it's really bad for publicity for companies that we have a concrete quality problem. So now we need to just find what is the forest big problem which we should be trying to solve. Then when discussing on developing new measurement techniques, I would say that it's helpful to distinct or separate at least two things. So we have productivity apps, and where the aim is to increase the productivity. And these usually takes more time to develop. Here's a couple examples: biomass estimation, logistics optimization, forest health status, and then we have also the helper apps. So these are faster to develop, and they give like there's one solution for one easy or like defined problem. For example, now when we have a harvester working in a forest, how we document the tree damage, what the harvester are doing. So, for example, this could be done in automatic way by using camera and some kind of machine vision. Okay, the spot rotten trees, maybe this is not really easy to do, but again, it's well-defined problems where you just need to get the answer yes or no. Okay, how to gather the data? Quite often, the manual measurement means that there's someone goes to the forest and do the measurement. And this is, I would say, the old way to do it. Now we have like better ways to do it. So harvesters are quite good platform for gathering data. They already have a lot of sensors and they are working in forest. So this could be utilized, and I'm sure it will be utilized. Then drones, I would calculate also the airplanes as drones, but I would say the drones has like bigger market opportunity. We don't need any pilots there. And then the satellites. Then technologies to watch. So I don't go too much in details because most of these have been already discussed today. But LiDARs, and I would say the time of flight cameras as emerging technology, this is the way to get the like dimensions of the forest. Then the hyperspectral imaging, I would say that this is like really important. We will see a lot of applications by using hyperspectral imaging, and this is way to get more information on the optical side, how things look like. And this is just the way how you can get more data than with normal camera. And then the part which was mentioned last year more is the microsatellite-based monitoring. So we will have like this kind of micro satellites going around the Earth, and we can get constant feed information. And it's quite crazy how we can even have startups in Finland who are doing this. These three are the really expensive part. We heard that this 40,000 euro like hyperspectral cameras. But I would also point out that these consumer level technologies are coming. So for example, Google Tango to get the dimensions of the forest. And good example is this development done in VTT, where they are developing this kind of solution where you could have hyperspectral camera inside smartphone without that the smartphone would cost thousands of euros. Before the measurement manufacturers will start to throw me bottles or something, this doesn't mean that you should not buy the 40,000 euro hyperspectral imaging or camera this year, because then you get the head start for developing the solutions by using that technology. Okay, thank you.
Thank you. So now it's time for questions. So first I would like to ask about those ecosystem what you are building up. So how easy is to get involved those companies and research institutes without any external funding?
Extremely hard, but we did it. So main in Finland, and I would say that this is global phenomenon, maybe not so much in USA, but to have like big companies which are competing each other, those companies make them to cooperate, it's extremely hard. And I guess that's why the usual way is that, okay, there's Tekes funding coming and it's force them to make cooperation. In concrete case, there is now why we were able to do it was because there's so big like pressure from public magazines and such that we need to solve this problem.
So you point out some technical from photonics side, but can you point out some technology need what your customers are looking for?
So for digitalization and IoT side, I would say that now we have quite good technology. The hyperspectral imaging, LiDAR, it's more about like make them more inexpensive. Of course, when we start to use more and more these devices, the prices will go down. It's not about developing again new technologies, is to how to make them more inexpensive.